Hello world, welcome to my channel. I'm Bound to Be Coding. In this series of quick tutorials, I show you a feature of my game and then I tell you how it's made. Today's feature, adding a command line dev console to your game. Let's get started. Before I show you the feature that I've implemented in my game, I thought I'd start with a little bit of history. Back in the 80s, when Microsoft first released Windows, it was not a full-fledged operating system. Actually, it was just a graphical interface shell on top of the MS-DOS operating system. And it wasn't until Windows XP that Windows became an operating system that did not require piggybacking off of MS-DOS. Many games in that era were also coded for the MS-DOS operating system. The idea of being able to get to a command line or a command prompt to do something special came from that era of computing. Some games retained this special developer-only feature in the final product, and players could eventually discover cheat codes and do things that they wouldn't normally be able to do in games using this feature. Now today this feature is commonly known as a command line or developer console, and that's where the terms come from. Okay, let me show you my feature. If I click in here, hit the tilde key, it brings up this little black box that is supposed to emulate a command line prompt. I can type something in, and if it doesn't recognize the command that I've given it, it will indicate that in the line above the input line. If I type in a command without giving all the information needed, it will prompt me with a usage prompt telling me what I need to do to actually use that command or implement that command. So if I do a create item and I give it the item definition key and I hit enter, it will create the item. And so it added this fire bow to my backpack. That's essentially it. It toggles on and off with the tilde key. How did I do this? How did I implement this feature? Well, let me show you. Let's jump over to some code. All right, we will take a look at some code in just a minute. I wanted to show you the scene first. The scene is very simple, not much to this at all. We have as the scene root, we have a canvas layer to which is attached the corresponding C# script. And below that we have a panel, and inside the panel, or as children of the panel, we have a label, which is going to be used for outputting messages to the user. And then we have an input prompt, which is another label, and it's just simulating the command line prompt character, the prompt character itself. And then we have a line edit, which is going to be our input mechanism for entering the commands into the game. That's it. Nothing much to this at all. So let me jump into code now and I'll show you how we get this working. Alright, so here we are in the script that's attached to the canvas layer of the admin console scene. And how I implemented this was to use a dictionary to store the action delegates. And as new commands are added, I'll just build this script, add more actions to the script, and then call into the dictionary whenever the console is used in the game. So a lot of this is just specific to my game. I'll try to highlight just some particular things about this that would be interesting to you if you were trying to implement this. One thing I did was I put a new style box in code rather than going through the Godot interface to create the style box the special style box, that is the panel with the black background and the white text, which is different from the style that I'm using in my game. So I just went ahead and added it here in code. I applied that style box to both the panel and also the input. The labels don't need the style box, so I didn't need to add those. And then when it initializes, I set it visible to false. This method here, register commands, is where we're going to actually load up the dictionary with the actions that we want to expose. And so for each one of the commands, we're going to register them here. I am essentially this here is the dictionary. This is my variable that represents the dictionary. So I'm giving it a key of, for example, set month, and then I am establishing the value of the dictionary as the following, and it's going to be these arguments. So this snippet of code here is where we're basically wiring up what we want the command to do. And of course this will be different, for any command that I give. I'm going to have to code it with the idea that when the user enters this command and provides the proper arguments, that I'm going to execute this code. So this is what's going to happen when they hit enter after the command. So for this one, this is my set month, and I'm not going to bore you with the particulars, because like I said, this is all going to be based on, if you're implementing something like this, then you're going to need to write the code to do the thing that you want done when this feature is used. So this is an example of an action delegate that doesn't have a return value. Actions do not return values. They just perform actions. If I was going to code an action that did return a value, then I would use a func instead of an action. So I have one command here for set month, and then I have another one where I'm adding to the dictionary set day. Here is the command for create item, and here is the command for create container. And that's the 4 commands that I have so far in my dictionary. And I chose to go very verbose with my commands, but these are just strings. These are string values, so I could abbreviate them, and it's pretty common with command line features that you abbreviate. So, create item might be CI and then a space and then the item number or something like that. And I may end up doing that. I may get tired of typing create-item and passing it the item number. So we'll see. But anyway, you can implement it any way you like. And that's the beauty of the command console system, is that you can build it out to do whatever you need to do. Now I'm going to use this. This is going to be very beneficial when I'm testing my game and debugging my game. And I often have wondered in the last couple of days since I put this together why I didn't do this several years back. But I'm glad I have the feature now, and I'm going to definitely get a lot of good use out of it. All right, so we have, I'm going to slide back up here. So we have in our ready function, we have ready method, we have the calling of the register commands. So as soon as this loads up into memory, it's going to register the commands. And this next method is just basically whenever the enter key is hit on the text, on the input, which is a line edit. So if you notice up here, I have the input here, and what we're doing is essentially wiring up here the text submit event. So I'm adding a an event to it, a listener, so that it's listening for the text submitted event. And when it does, I output the text that was submitted, and then I call process command and I pass it the parameter. So jump down to process command. This is very, very simple. What it does is it takes the input, whatever the user types into the keyboard, and once they hit enter, process command takes place. It gets called and it breaks the parts, separates it by a space. It checks the length. It wants, basically what I'm doing is I'm saying, okay, how many pieces of information do we have in that line edit that the user typed in? And if the part lengths is 0, it means that they basically went into the line edit and they just hit enter. So I'm going to clear input and go back and just forget about it. We're not going to do anything with it. Otherwise, we're going to take the first part of the line input and we're going to make that the command. And the second part of it is going to be, in fact, any subsequent part is going to be the arguments. And so we're going to take parts and we're going to skip the first one, and everything else is going to be our arguments that we're going to pass into the action. And here what I'm doing is I'm calling the command, I'm basically checking the command dictionary, and I'm saying, hey, I want to try to see if I can get the value that was passed in, and we're going to call that value. We're going to output that try get value. We're going to output it as variable action, a variable called action. So I'm checking the dictionary for the command, and if I find it, I'm going to invoke that action. So this is where we're invoking the delegate that's embedded inside of the dictionary, and I'm passing in the arguments. If it doesn't find it, then I'm going to report back or respond with a response not recognized. And this is just an extra method that I added. This is just for code organization, really. I have 3 responses that are possible in this system so far. I can respond to the user with a not recognized. I can set the output text, that first line at the top, set the text to show the user that, hey, what you just entered is not recognized. Then I can clear the input. Another response I can give is the respond with a hint. So if the user enters a command and it's the right command, but they don't give me enough information, then I basically give them the hint. Or the third is to respond with an invalid command. So if the command isn't valid, it's an invalid command. It doesn't match anything that we have in the dictionary, and it is thus invalid. Probably could wrap both of these into the same, but really depends on how I want to word it when I'm sending it back to the output text. With this one, I wanted to identify the command and say that it's not recognized, and in this method or this scenario, I wanted to call it invalid. Can handle it any way you like, but the idea is that you're providing that functionality. All right, so whenever the process command is called, we're going to invoke. So let's go back up, and again, we can take a look at any one of these. This command here, create container, and I'm checking the database. So, and the important thing with the commands is that they are coded in such a way that I can handle any scenario that's thrown at it. I want to make sure that I catch anything. I want to make sure if there are any limitations in the parameters that are sent. Like, for example, if we come up here and we look at this first command, set month. Well, in setting the month, if the user types in set dash month and then space and then hits or enters a number, well, I want to make sure, number one, that it is a number. So I do an int try parse and I output that to this new month variable, and then I check it. if it's greater than or equal to 1, or if it's less than or equal to 12. That's what I'm qualifying. And if it is, then I'm going to continue. Otherwise, I'm going to say that the response was not recognized. And so this has to be robust enough to handle this, whatever situation or whatever scenario is that the user's typing on the command line. Now, the important thing about this, and this is what's really cool about putting these actions in the dictionary, is that when the game is compiled and the game runs, when the game runs and this register commands method is called, what happens is the commands are fed into the dictionary at runtime, which means the actions are stored in the dictionary at runtime. If I were to put a breakpoint here and a breakpoint here, for example, and if I were to run this and execute this, then what would happen is the first time when it initially calls the ready method here, I'm going to hit this register commands, and it's going to come into this method, and my breakpoint is going to stop right here because this is where I'm registering the commands. However, when I actually execute the commands, when I actually call in to the dictionary via the process command method, and this actually invokes, the action gets invoked here, and I pass in the arguments, what is really interesting about this is that this breakpoint here will not hit. And the reason is because since we are storing this in the dictionary and it's getting at runtime compiled into the dictionary, the action itself, the delegate, we're not actually running this code at the moment that the command is given. We are invoking the action that is already stored in the dictionary here. So this breakpoint would never hit. And I think that's really cool. And that's one of the nice things about using a dictionary to store the actions. You may not have known that you can do this. You can create action delegates, store them in a dictionary, and then call them directly from the dictionary, and they actually run from the dictionary. They're not actually rerunning this same code. This code was compiled and stored in the dictionary as an action delegate, which I think is really cool. That's really all there is to this. And I'm sure I will continue to build this out and make it more and more robust over time. But as you can see, there's not much to it. It's as powerful as I need it to be. I can add new commands to this. Some of the things I could have done differently, I could have placed this class into a singleton and loaded up in my list of singletons. If I jump back over here to Godot, go into my project, you can see here that we have our auto loads. These are all my singletons. I could have put that code in the singleton and then called it. Another thing I could have done differently with this, right now I have in my game interface, I actually have that scene dropped in here. And what that is going to do is that when my game interface loads, this admin console is going to load into the scene tree, and it's going to stay in the scene tree the duration of the game. What I could have done instead was have in my script for my user interface a check for the pressing of the tilde key, and if the key is pressed, I could have loaded it into memory dynamically. I may still do that, but for now I have it just as a part of this scene, and when I don't need it, I hide it, and when I do need it, I show it. And that's essentially it. This is a very simple but extensible system. Well, I hope you've enjoyed the video today. If you have, please give me a thumbs up. And if you'd like to see more videos like this, please consider liking and subscribing. And until the next video, I'm bound to be coding.